All right, you're welcome to this class. And this experiment, remember, this experiment, I want to set it up this way. Okay? And I also did a manipulation where I did a setup, which is already there on the video. Okay? But this one now, we were able to set it up like this with the students there. Okay? So what we are going to do is, first of all, we started with this. When we practice with this circuit, we remember that this is the standard resistor. And the standard resistor I mean is this. This is the standard resistor, okay? Now, with this standard resistor, you know, Waec gave us a value. I'm not going to tell you. So that standard resistor was said to be recorded as R sub X is the value of the standard resistor, okay? Now, what I am very sure Waec wants to do is for you to plot your graph and find the value of that resistor. Are you getting me? Because see, if Waec does something different, how are you going to be able to know what the person's answer in this particular school is, and another school will also have a different answer? So they want everybody to have a particular answer. That is according to my own analysis. I think they want to find the value of that what? Resistor. The way I explained it in the other video was also to find the value of the resistor, which I'm going to do after now to teach you people. So those of you who have not watched the video. But see, if I set this up like this, this is my battery, okay? Later we'll go to the experiment and do it and see what happens. This is the battery. Battery is connected to this resistor, okay? Then this is the ammeter, which is connected in series. You know what I mean by connected in series? So connect it along. Then remove this one, for example. If you remove this, you just connect it back down. Remove this one as well. So this is what you have. From the ammeter to the what? Potentiometer. Okay? When you connect it to the potentiometer, you get back to the key. Alright? So when you close the key, what happens? This ammeter is going to read what? Record the value of the current. Are you with me now? The value of the current is recording. Is going to tell you the current flowing through this given resistor. Okay? Now see what happened. If I now connect my voltmeter, which is this. You know how to connect. Now use one wire, one length of the wire, this side. Take one place, okay? Take one wire from here. Join to the end of the potentiometer, okay? Carry this last terminal, join to the other end. Are you with me now? That is the voltmeter for you. So when you do that, what will be happening? This particular voltmeter is going to be recording the voltage across the length, 100 cm length of the wire. Are you getting me? Please, you can ask questions if you like. So from here, from P to Q is what? 100 cm wire. Are you getting me? Now see what happens. You should know that voltage is directly proportional to what? Length of the wire. So when you have 100 cm length, what will happen? You are going to measure the what? The highest value of the voltage. The highest value of the what? Voltage across PQ. Do you understand what I'm saying? No, you don't understand. Are you sure you understand what I'm saying? Okay, what am I saying? Tell me what. Collect mic. Where is that mic? No, please, you are learning here. I don't want that. This is physics. In a physics class, collect this mic and tell me. What do you understand? You are not playing here. Informer, do you have anything? Who wants to talk now? Collect. Now, so what do you understand from what I explained here?
What I understand?
See, this is a learning time. So please, let's open our mind and learn.
What I understood is that in order for us to, find the voltage or the resistor running across this resistance running around this circuit, we need to find the voltage using the length of the potentiometer.
Find the length of the voltage.
We need to find the voltage using the length of the potentiometer.
Okay, fine. Yes, potentiometer measures voltage. It also controls voltage. Yes, that is true. So what I'm saying is, what happens from P to Q? What is this thing measuring from P to Q? What is it measuring?
The maximum voltage in this circuit.
The maximum voltage in the circuit.
Yeah.
Yes. Who else has something else? Yes, Ifama.
The voltage is measuring the potential difference.
Close that window. Yes.
It's measuring the potential difference across the potentiometer, which is PQ.
Yes, correct. Now, if I include my joking, what do you think that will happen? No, but before that, see what the guy says. See what she's saying. She's saying that you know that the length is what?
100 centimeters.
100 cm, right? So the voltage this V is going to measure the potential difference. That is the voltage for 100 cm. Voltage for what? 100, the whole of the cm, 100 cm. But when you now put this jockey in, what happened? You have reduced the length. Are you getting me now? It's like everything now is no longer connected. Everything is now just connected at this point. It's just like this. Have you seen it now? The value of the length is cut out. Are you with me?
Yeah.
So what will happen to this value of the voltage? You have divided the voltage. Please give out the mic to repeat that thing. What do you say that happens to the voltage here?
You reduce the length, that means you have divided the voltage.
Good. The voltage has divided. And that is why potential difference also helps in doing what? Dividing voltage. You cut, because it was 100 cm length. Are you getting me now? Now you measure, maybe 30 cm. You measure this part. You are measuring from here to here. Maybe let's say 40 cm now. The first one was 100 cm. Now you are measuring 40 cm. The length has what? Reduced. Therefore, the voltage is going to do what? Reduce. That is the essence of this experiment. Now, in that case, for this case, you may decide to say V. You are plotting V against what? L. In this case, what are you looking for? Who can tell me what you are looking for? Give a mic. Give a mic. You said we are looking for what? Give a mic. Smart children. We are looking for what?
The constant.
The constant. What is the constant in this case? No, not current. The what? Give her a mic. She said K. K. We are what are we measuring?
K.
K. What is the K?
The resistivity.
The resistivity. Why are you telling me RS? We are not measuring. No, with this kind of measurement, we are not even interested in this one. Are you getting me? We are measuring V. Guy, listen. We are measuring V with the current across it. Because the same current across this and this is the same current flowing here. Therefore, we are going to say that V is equal to what? KL. What is K? The value of the length of the wire, the resistivity of the wire. But that's not, I don't think that's what Waec wants us to find this year. We are looking for what? R sub X. Now, this is where I now have to set the equation in a different way. Are we together now? And this is where I'm going to make us to practice. So in this case, I'm not even using rheostat, because what rheostat is doing is the same thing potentiometer can do. When potentiometer length is changing, what is happening? The current will also change. Is it not true? Yes. We did it. We have already said this up. We practiced it before. What we are doing here is just physics practical in its natural way. Now look at this. When it comes to this part, there was one confusion that I was having. The confusion was this. Remember, this is a full circuit. This is from P to Q. In this P to Q, we also have a resistance along PQ. So I said that resistance along PQ is directly proportional to what? To length. See, one of the essence of physics practical is to reduce confusion. Reduce confusion, reduce the problems there, in order for it to be measurable. And so that you'll be able to find what you intend to find after the experiment. My intention is to find what? resistance, R sub X, which Waec has told us to use. Waec said we should use a particular resistor. I'm not going to tell you because it's a white paper. Professionally, I'm not supposed to tell you the value. So what we are doing is the value of a resistor which we do not know is our intention to find. Now let's see what happened. Are we together? Are we together?
Yes, sir.
If you do not understand, it's better you ask questions. You asking me a question can even help me to teach you better. Now, see what happened. After connecting this way, let's assume I am not including the jockey in the first place. When I don't include the jockey, I connect everything. This is the voltage, which is measuring the what? The resistance. The voltage across the resistance. Why this is the current? This is ammeter, which is recording the current in the whole circuit. Because if you remove this volt now, see what you ask. This is the circuit. Nothing. What is this? Resistance of PQ plus resistance of the standard resistor, which is unknown resistor. Are you getting me? Good. So when I came here, I said, okay, good. I have resistance of the PQ. Every length of wire is a resistor. Are you with me now?
Yes,
so resistance of the length of the wire, and then resistor or resistance of the unknown resistor. According to Ohm's law, they will tell you find total resistance or combined resistance. Is it not resistance of the PQ plus resistance of this place? Is it not what we call combined resistor? Yes. Effective resistor. So I call it as this plus this. Multiplied by the current, this is the combined resistor, total resistance. I told you that any day you come to physics lab or physics class to write this, V is equal to IR. You have put yourself inside a problem. This is a problem you are having. Because this formula does not represent the true definition of what you are asked to find. Except you find it, call it what? Total resistance of the circuit, which you have to find either through parallel arrangement or through what? Series arrangement to find the total resistance, which is the resultant resistance in the circuit. So because this one is connected in the same way, it is connected in series. So I said this plus this times the current flowing through them is equal to what? Total voltage in the circuit. But guy, that was a confusion I'm trying to put myself into. And for the sake of Waec, I have to come back. I say no. Let's not go into total resistance and stuff. Let's get back to this guy. I have to connect you into what? Parallel. Voltage must be connected across the standard resistor. Are you with me now? Yes. I say let's go back to what? Verification. Verification of what? Ohm's law. Verification of Ohm's law. In order to find the value of R sub X. Are we together? Yes. Now, what I did was I said, okay, for this reason. Now, one more thing about physics practical is this. It's so funny. You have a question? You have a question? I will give you my mic so that you will not be worrying my video. Thank you very much. God bless you. You are in the physics class. You cannot ask questions. That means you are not learning. you cannot ask questions. You are not playing. You are playing. Now, see what happens. See what happens. Now, in physics lab, something must change for something else to change. Do you agree? If there is change in price, there must be change in what? Quantity demanded, right? Or even demand, or even taste. Can taste change because of? Okay, taste will remain constant, but decision making will also change. That's the same thing. When we change, hello, let's come. When you change the length of the wire, what do you change? You change the total resistance. Therefore, total resistance has changed. The value of the current will do what? Change. And the voltmeter must also what? Change. So, in this case, what I will do is this. What I will do is this. I'm going to bring my watch, jockey, to put at 35 cm. When I put it at 35 cm, this value will change, and this value will change. Are you with me now? Now, according to Ohm's law, the voltage across a given resistor is equal to the current across this resistor times the value of the resistor. Are you with me now? So if I plot a graph of volts voltage across the resistor against the current in the circuit, I'm going to have what? A straight line graph whose slope is given as what? The value of R sub x. Are you ready for that? Yes. Let's go to do it in practical. Thank you very much. Bob, do you have any question? Yes. Okay, give him mic. Give her mic, sorry. Oh, yeah, take it. Yes.
Sir, if the potentiometer was not to be used during the practical and were asked to use the rheostat instead.
Smart girl. No wonder it's got 362. Go ahead. What did you say? Go ahead. What did you say?
How are we able to determine or to find the fixed point of where we're going to be adjusting the rheostat to?
Oh, smart. See, I have done this. If you go to exam guide, I did this kind of experiment. But in that case, you are not. See, you see potentiometer, rheostat, and the one they call resistance box. All of them do the same thing. Vary resistance. Now, if you are using rheostat, the simple thing. Oh, this guy are too good. What they will ask you to do is increase your rheostat to any personal value, and for any small increment, record the value of voltage and the current. You increase a little, you record this. You increase a little, you record this. You increase the same thing. 35, 45. Do you understand that? See what I mean? For every jockey length, for any length we put here, we are varying the total resistance. Therefore, current must react, change, and the voltage must also change. That is just it. Any other question?
Yes. So supposedly, let's assume that you wanted to plot voltage like against on the y-axis and the length of the potentiometer you're dividing. If you want to plot that, sir, how will you relate current to the graph that you want to plot?
Another good, very good question. She's now saying, no, that is called 300 what, 20? 336.
13.
Okay, 313. Correct. Stay there and I'll be playing. All right, so you said if we are to plot the length against voltmeter.
Voltage.
Against voltage. Okay. Let me see. You are asking me a question I cannot answer. We'll just close the camera. Everybody will run. Okay. Please, if I will, because let's see, the girl is saying, let me even reason that now. If I'm asked to plot length, okay, because the table is going to be length in cm, right? V in volts. Why are you asking me this kind of question? Okay, you would have kept it simple. All right, see, we say 35.00. Okay, what will happen? Okay, see, I have no voltmeter here to pay attention. I have no voltmeter here to record the value of the voltage, the length. Therefore, I can plot L against I. That's what I would do. Because this V sub x is not recording what happens between PQ. It's only happening. It is changing the value of the energy that will push the current across R sub x. Because this guy is bringing a level of resistance to stop the current flowing. So him is the pressure that is pushing it across this guy. But I do not have, unless I'm going to put something here. Are you with me now?
Yes, sir.
To record what happens to the voltage for every change in length. Please, can you clap for me now? Yeah, are you okay? People don't know. People don't.
The clapping.
Okay, yeah, that's good. Okay, so that is what I would do. Uchechi, that is the only thing I could do. If I put V here, I'm going to record each length per V. But if I don't want, I can record, even if I remove this now, okay? I'm going to record length with respect to what? I am sure I may have either inverse.
Yes.
It's going to be inverse because length will be increasing. And no, length, it will be inverse.
Yes.
Do you know why? Because if I put at 35, it means I'm recording 65. If I put at 45, I'm recording what?
65.
Are you getting me? That's the meaning. Yes, we are just so if I do what you are saying, it means I'm not going to be finding R sub X. I'm going to be finding the constant of the length of the wire, which is the resistivity of the wire. Thank you very much, please, class. Let's go to please clap for me. Thank you very much. Let's go to all right. Is there anything wrong? Has it stopped?
No.
Okay. Thank you. So what we are doing is let's go and do the main experiment. Thank you very much. What did you do? All right. So we want to do the setup. Okay. Now, like I said before, the setup must follow the guidelines I have on the board. So we are going to measure either V sub X, this one, and the current across, recording the current in the circuit. All right. What PQ, which is the rheostat, is doing, what the potentiometer is doing, rheostat can still do the same thing. So that is what we are going to do. So I'm going to start with my battery. My battery is going to the key. Wait now. The battery is going to the key. All right. So let's go. So this is my battery. Okay. You can also have different wire in your own school depending on what they bring the camera close in there. Now, this is my key. We don't want stress. We just slot in. Do you understand? Yes. But then I don't know which one is positive or negative. It doesn't really matter because the current here is not too much to shock anybody. But for the sake of professionalism, this is the positive side of the battery, which must go to the key. All right? Okay, so this is positive side of the battery is going to the key, and then from the key I enter point P of the potentiometer. All right, so I'm going here. So let me give the wire a little freedom. So let me give it a little freedom. Extend the length a little. So this is my one enter to the potentiometer, right? Yeah. So the potentiometer goes straight to Q, right? This is Q. Now let's go to the board. Then when I get to this Q, I will connect a wire to what? All right, so now this is at point Q, right? Then I will enter my ammeter. Okay, I will just bring that one. What is it? So, smart children. I will enter my ammeter, right? From my ammeter, okay, to the resistance. From all of you shift so that you can. All right, come this way. So this is my ammeter, right? I'm using 2. So I will connect the ammeter to my resistance. I can use 2 or 1 ohm. But the higher the resistance, the lower the current. Okay, fine. 1 ohm resistor, and then from the resistor I go back to the battery. So this is everything I have connected. Okay. So this is what I have connected without my jockey, right? Now let's connect jockey. So this is my jockey. I made the jockey wire to be long so that it can stretch. So I'll still connect it at P, right? So this is, let me extend it a little for it to have freedom. So I'm sure you guys can connect it tomorrow. All right, so this is what I have, okay? Now, according to the rules, what we are trying to learn, okay, so at this point, I'm not going to change anything. I'm not going to, let's just measure the voltage and the current. Well, let's measure the voltage. Guy, stop the noise now. Let's measure the voltage and the current when no jockey is connected. All right. So let's close the key. This is the key, right? I'm closing. Where's my voltmeter? I've not measured. Let's connect voltmeter. Parallel to the circuit. So please, someone is coming to read. Ifama come and read. Or Tobias, come and read. Tobias and Ifama come. Okay, now this is the setup, right? You'll be measuring. You also make us see the voltage very well and the current very well. So let's close the key. I'm closing the key. I'm closing the key right now. When I close the key, the voltage is overshooting, right? The ammeter is not reading. It's not reading. It's reading. Okay, pause. Now, when I close the key, we have the reading of the voltmeter and that of the ammeter, right? So I hope every connection is good. This is V naught. And this is I naught. So please, if what is the value? You check, come out. I naught is 0.35 amp. Value of the voltage 0.8 0.82. Okay, so I'm having 0.9. This one is this is over. So let's 0.1. 0.9 is okay. Then this one still stable, right? Yes. Good. All right. So let's go. So that is the first reading, right? So my V naught is what? V sub 0 is what? 0.90, right? Volt. What is my current? 0.32. 0.32 ampere. All right. So that is what we have, right? Yeah. So now let's go and make our L to be 35, 45, 55, 65, right? That will be enough. So let's plot the corresponding current. So we are going to plot the graph now. Okay? All right, let's go. Now, coming back here, I'm putting my jockey. I've closed the key. I've closed the key, right? Now, I'm going to measure my 35. This is 35, right? Yeah. All right, let's measure the corresponding value of voltmeter and current. Sharp, 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 sharp. Where are my people? No. Come on, do reading. You are parallax error now. I know, parallax error. 0. Okay, this is 0.85. 0.85. Somebody should read the current. What is the current? Come on, help now. Faith, why are you having issue? 0.35. Have you recorded the vote? Current is what? 0.35. Come and confirm. 0.85. All right. So the value currents are what? Vote 0.85. Vote 0.85. 0.35. So his current is increasing. Yes. Voltage is reducing. Is it true? Is it supposed to be? Yes. Are you sure it's supposed to be so? Length is not actually increasing. Length is reducing. Voltage is reducing. Length is reducing. Voltage is what? Reducing. And the current must what? Increase. Because when we put it at 35, voltage has reduced. Yes, we have cut out 35. We are now measuring 65, right? So because the resistance has reduced, current must increase. Very perfect practical. Let's go to the next one. Please reduce that noise. I'm closing the key again. Next one is going to be at 45. Tell me what you saw. 0.87 volts. It can't be that. Come and confirm.
0.8.
Please, if Former, come and read now. Come and read.
0.8.
Confirm. Somebody confirm.
0.8.
0.8. What is the current?
0.4.
Hmm?
0.36.
0.36. 0.8. 0.80. 0.3 what? 6. Now the changes may be too small, but you need to be very sharp to catch it. Somebody else, come and position yourself. Position. Filter, why are you taking this thing so long to read? Video is on, right?
Yeah, next one 55.
55 centimeter. Hey, wait. All right, at 55.
It should be it's so small. 7.9. It's 7.9. He's even going forward.
No, it can never go forward. A little, anything, maybe because of yes. Current was what? It cannot be. Something is wrong. So if you have this kind of problem, you know what you do? Manipulate the rest and move on. I did it. Is it increasing? Okay, which is okay now. So the next one, let's do the last one and see. Because you do know normally, it's even normal to have an experiment like this where something is moving a little different. It's also possible. Human error and so many issues with this instrument. It's possible. So it's not a problem. You record what you have. All right, so let me do 55 once again to see what happens.
Measure the voltage. The current is increasing now. The current and then the voltage. The current increase.
Current increase.
Yeah. But the voltage decrease. The voltage is decreasing like 0.78.
0.78. 0.78. 0.78. Why this one is what? 0.38. So this is why we are going to draw the curtain, because even if you do, we are going to be having 2, right? 0.02. So let's say 0.75. This is 0.3 or 0.440. Thank you very much for being part of the class. Let us plot the graph. You say? That video. All right. Thank you very much. Thank you. All right.